Good morning, ladies and gentlemen, and welcome to our DCS webinar this morning. Many thanks for joining us today. We really appreciate you coming along. Before we start, our usual housekeeping rules. To simplify proceedings, all our guests will be muted during the presentation and the question and answer session. But once we get into the question and answer session, please feel free to use the chat box at the bottom of your screen on the right hand side, where you will be able to ask questions and we will answer as many questions as possible. So today we're going to be looking at our DCS5 system, and in particular we're going to be looking at the infrared and ultraviolet modules that we sell. But first of all, a quick recap about our DCS system. Our DCS system is our digital capture system, which is our comprehensive workstation for the digital capture and enhancement of fingerprint images, shoe print images, or in fact other forensic images as well can sometimes be enhanced using the DCS. And the DCS has been sold to over 50 countries worldwide. And from this map you see on screen now, basically almost every corner of the world is using DCS, and many countries also have a lot of DCS systems like UK, USA, China, Italy and Colombia, just to name a few. They're some of our biggest customers for the DCS system. Now the DCS is a combination of three different areas. First of all, we have the camera system, which is a high specification digital SLR camera, which is able to photograph in the UV, infrared and visible spectrums. Then we have the illumination. And illumination is perhaps the most important part of the DCS system, because it's what you do first of all. When you get the illumination right, the fingerprint image is already enhanced a lot. And if you get the illumination right, the camera can take a good image. If the camera takes a good image, the software can then do a good enhancement. Finally, we do have the PC and software that does the enhancement, but also a lot more. The software does an authentication of the images so that we can prove that the original images has not been changed or tampered with, and we also get an audit trail so that if we have to take our evidence to court, we're able to show the original photographed image, we're able to explain via the audit trail exactly what has been done to the image, and then finally we're able to show the enhanced image. And continuity of evidence, being able to prove what you are doing, is very important if you want to be successful in court. Now, looking at the DCS system, we often refer to what we call our core system. And the core system, if you like, is basically the DCS system that enables you to photograph in the visible part of the spectrum. And all early DCS systems, so they would be DCS 1-to-1, DCS 3, DCS 4, and in fact early DCS 5 systems were only capable of photographing in the visible part of the spectrum. But while we've been developing DCS 5, we've actually been able to develop the technology to photograph beyond the visible and into the infrared and the UV. And as you're going to see today, there are some exciting benefits that enable you to find more evidence and also photograph difficult evidence more quickly. And these will enable you to save both time and money within the laboratory.
So I'll begin by explaining the equipment required for reflected UV photography. And essentially there are only three components. The Crimelight 82S UV with the mains power supply, 60mm quartz lens, and the UV pass filter that will attach to that lens. We also supply, as this lens is 60mm and is a shorter focal length than our standard 105mm lens, we do supply a range of extension tubes that you can fit to this lens to allow for greater magnification ratios when photographing small items such as fingerprints. So the first sample that we'll look at really demonstrates the versatility and the usefulness of the reflected UV. And this is just a white container that has been superglued. So this will clearly demonstrate the potential problems that you have with supergluing a white item, whereby you have very little contrast between the fingerprint and the background. So this would traditionally have to go under another subsequent treatment, normally some kind of fluorescent treatment such as a dye or maybe a powder. But here you'll see that that step is not required. So we can simply place this under the camera. We are using the live mode in the DCS as we will not be able to look down the camera itself because we're only seeing ultraviolet light. Switch on our crime light and then we can just start examining and searching for fingerprints. The reason again that we use the crime light 82S is that it can be very flexible in the positioning of the light, and you'll notice in certain situations, here we have a nice fingerprint that, depending on the position of the light, it can dramatically affect the contrast that we see. So in the majority of situations, not all, we find that using or having the light at a more oblique side light angle, we get the most contrast as we see here. So I'll capture this and show the detail that we can see. So this is our final processed image where we've simply inverted, converted to grayscale and applied a simple superglue enhance. Our next example is this clear glass container, and this highlights another benefit of reflected UV. So even though the superglue marks are of good contrast on the clear parts of the glass, and we would be able to photograph those relatively easily using normal visible lighting, although we would have to battle a little bit with reflections. The label will present a little bit of a problem as the contrast is not very good here, and again, if this was being treated with a fluorescent dye, then the powder or liquid dye would probably be very absorbed on this area here, so this might not be suitable for that type of treatment. But again, we'll show you how this looks straight out of the superglue cabinet using the reflected UV technique. So immediately we can see an abundance of fingerprints, but just how clear they are and the lack of reflections. Once again, you do have to be a little bit careful where you position the light. So if I'm a little bit higher, we do get some reflections and very little contrast. But as soon as I move the light to more of a side angle, you can see we get much higher contrast, and we can see quite a few fingerprints on this area here. This area here is also worth noting as we have a fingerprint here that is partly on the glass and also on the label. But you can see we have very good continuation of ridges across those two very different mediums. On the reverse side of the label, which is incidentally white, so again provides very little contrast against the white superglue marks, we also have a nice fingerprint here, but you can see where there are the areas of black text. But again, when we're using reflected UV, the text, although is visible, we are still able to see the continuity or the continuation of the ridge flow through those areas of text. To demonstrate that you can use reflected UV on other samples and not just cyanoacrylate marks, here we have a metallic knife that's been processed using our recover system. So again, this has just come straight out of the recover and no subsequent treatments have been applied to it. So again, we can see with the reflected UV, we have a fingerprint in the middle here, but again, because we have these striations in the metalwork, It's all about, again, positioning the crime light in such a way that we have good visibility of the fingerprint with minimal background intrusion. And you can see if we manipulate the angle, you can see here where we're picking up more of the striations in the metalwork and less of the fingerprint. But here, more perpendicular to the fingerprint and at a lower angle, we are seeing less of the background and more of the fingerprint. So we'll now move to the other end of the spectrum. So we'll now be talking about infrared. And we'll first look at infrared fluorescence, primarily looking at examples processed with our natural 1 and natural 2 powders. So for items processed with these, we will primarily be using the Crime Light 8x4. So this looks almost identical to the Mark II, but in this case we have just blue, red and infrared wavelengths of light. But still 32 LEDs in total. We will be combining the light source again with filters, and we have specific filters for natural 1, which are these red coloured filters, and filters for the natural 2, which are these black sharp cut filters. So to demonstrate the infrared fluorescence, the sample that I'll first look at is this drinks can. So a very common and familiar item, and again this would be a classic item that would be processed with superglue. So this item has in fact been processed with superglue, but then we have applied FP Natural 1 on top of that. So that also demonstrates that the natural powders can be used subsequently after previous treatments, or straight away on latent marks as would be with any other powders. So we'll have a look at this first with the Crime Light 8x4 and see the results. I'm still using the quartz lens, however we've removed the filters from the lens itself as we will be using the Crime Light filters instead. So for FP Natural 1 we can either use the blue light or red as the excitation source. So we'll start with blue. And again, because this is a non-visible technique, we will have to use the live mode within the camera. So this demonstrates that we can see some fingerprints, although the fluorescence is a little bit weaker, but we are also getting interruption from the background, particularly the Coca-Cola logo here. If I switch to the red light, you can see immediately the benefits of these natural 1 powders. So in this example, the background has been almost removed entirely, and we're getting much stronger fluorescence from the fingerprint. And here I will take a preview and enlarge this particular print here, and again we can see the amount of detail that we can see. So easily first, second, and in some places third level ridge detail as well. Another example is this polymer banknote, and this will demonstrate the primary reason why the FP Natural powders were developed, and that was when the introduction of polymer banknotes in the UK. So here I have just a sample polymer banknote, and this has been developed with FP Natural 2. The primary reason for Natural 2 over Natural 1 is generally we find we get a lot less background fluorescence, principally because our excitation light is infrared. And many of the security features, particularly on banknotes, but also on packaging, they generally do not fluoresce, or fluoresce to a much less extent. So we are able to get much better contrast between the background and the fingerprint. With FP Natural 2, our excitation light can either be red or infrared. So primarily we will be using the infrared, but because the fluorescence is quite a bit weaker in some cases, the fingerprints are much more visible in red. So we can sometimes locate our fingerprints using the red and then switch to the infrared when we know we've got good fingerprints and good focus on our sample. And for Natural 2, we will also be using these black labelled sharp cut filters on the 8x4 Mark IV. So we'll first start out by looking at the sample using the red light as our excitation. And here we can clearly see a number of fingerprints on this sample, but we also have a lot of background fluorescence, so particularly these whiter areas here and some of our background text and printing. So I'll just take a preview of this so we can compare against the infrared light in a moment. So I'll return to live mode, And now with the same filter on the crime light, simply switch to the infrared light source, and you can visibly see already that the fluorescence is much weaker, and as I start to increase the shutter speed, we do get a lot more noise in our live mode, but that noise is only present in our live mode, and as soon as we take a preview, you'll see that we get a much cleaner image. And we should find that our background fluorescence has almost completely disappeared in most areas, and we are in most cases just seeing the fluorescence from the fingerprint. And for comparison, this is the result using the red light as our excitation, and this is our infrared. So we can clearly see how significantly we've reduced the effects of the background fluorescence by using infrared light as our excitation. Another application within the infrared spectrum is reflected infrared. So in this case, we'll be using again the 8x4 Mark IV with our infrared filter, and we'll be using the infrared light source itself. And the sample that we'll be imaging is this drinks carton. So it's a non-porous sample, and in this case this has been treated with just normal black powder. But the issue we have is, although we can see the fingerprint marks on there, we are getting a lot of interference again from the background. So what we can do is, if for example we've already screened this item with the MLD and we've already observed that the background drops out or disappears, then we know that we're going to get a good result using the powder, as that will not disappear. So hopefully we'll see a good example between being able to see the fingerprint and the background dropping out within the infrared. You really see a series of fingerprint marks, and the majority of the background has dropped out. It's only the main parts of this black printing, which in the majority of cases doesn't intersect with the fingerprint at all. So this is a classic example of the benefits of infrared, where we're still able to see the fingerprint, but the background has dropped out. And for reference, this is what the sample looks like under normal visible white light. So another example is a banknote here, and again, using the reflected infrared, we can exploit the security features whereby generally a lot of the background will disappear in the infrared. So we have a sample of a €5 here. It's not a polymer banknote, it's just been laminated just for protection, as it's a nice training sample. And this fingerprint, we have a series of fingerprints that have been powdered, so just to protect them, it's just been laminated. But it will be exactly the same even if it wasn't. So we have a couple of marks here, and again, although we can quite clearly see the fingerprint, we are getting a lot of interference from the background. So we can clearly see, just by placing the sample under our infrared light with the infrared filter, the background has completely dropped out, and we can see essentially nothing but the fingerprint. So again, this is a nice example where if we know the background disappears, then we can process the fingerprint in a way that maximizes the contrast between the fingerprint and the background. In this example of reflected IR, again we'll be looking at a drinks can that's been developed with superglue. So superglue only, but this is also showing how, again, we can use the reflected IR to drop out the background, but also increase the contrast on the superglue mark in a similar way to the reflected UV. For this we'll be using the FLS light source, which at the moment is using a white light. So once again, I'm using the quartz lens with no filters attached because our filter is in the FLS itself. So in this case, we're focusing on this particular fingerprint here. So I'll just adjust the shutter speed so we can see that a little bit more clearly. So again, you can see the areas where we have the interference from the background using the white light at the moment. But with the FLS, we can change the wavelength to any of the colors, but then also go beyond that within the infrared spectrum. So in this example, as I click up into the infrared, we can see here where the background, the blue areas that were causing a problem, have completely disappeared, and the contrast from the superglue has increased dramatically. So we can fine-tune the exact wavelengths, and in some areas the contrast may drop a little bit, and we might bring some of the background back, so we can just experiment to get the optimum contrast by using the fine-tune possible with the FLS light source. So in this example, we'll demonstrate the infrared light within the PLT and combine with the CSU. Here we have an example of just a small part of a metallic bar that has been developed with super glue. So we'll demonstrate in this case where using the infrared we can get some really nice contrast of the super glue marks without having to treat it with anything else afterwards. So we'll place this in. And then we already have our infrared light on, as indicated by the light here. Of course, it doesn't look like there's light on because it's infrared and we ourselves cannot see it. Once again, in this case, I'm using the quartz lens without any filters because we're using a dedicated infrared light within the PLT. So in the software, once I've set the diameter of the item and chosen the area that we wish to capture, our sweep angle, motor position and the diameter again, we'll just click set, click start, and then the unwrapping process will begin.
So as you've seen, the UV and infrared imaging modules are an incredible addition to the fingerprint examiner's arsenal. It will enable you to find prints that were incredibly difficult or even impossible to visualize before. And using these new techniques, we can often visualize prints more quickly and easily using less powders, less chemicals, and quite often retaining more DNA as well. So all our customers would benefit from the two techniques that you've seen. Current DCS 5 users, DCS 4 users can upgrade to use these technologies. Depending on how old your system is, you may need to upgrade the camera and some other parts as well. But because the DCS is modular in its design, nearly all users can upgrade, but some users will need more equipment than others. For those of you that missed our previous webinars, we'd really suggest you having a look at either the DCS 5 webinar that we've done previously, and also, as you're interested in fingerprints, we'd also recommend having a look at our full spectrum forensics webinar as well. And like all our other webinars that we've done, they're all available on demand on our website. Go to the website, go to the webinars tab, scroll down, and you will see all the previous webinars that are available to watch on demand at any time that you wish to. So that covers our webinar today. Thank you very much indeed for listening. We're now going to go into our question and answer session that will be hosted by myself and our application specialist, Mr. Dan Freeman.